Uh, so today we're going to be talking about a pretty interesting problem. We're going to be talking about the Josephus problem. So this problem has been around for a while. If you have any extra time after this, we'll go over a few math puzzles. So yeah, let's get started. Okay, so this is a pretty interesting scenario. So basically what happens is we have a few people in a circle here. And so we'll go around the circle, and each time the person will tag the person next to them. So in this case, person number one would tag person number two. If you're tagged, you're out. So the last one standing is the winner. So yeah, we'll go through this scenario real quick and just see who wins. So the goal today is to try to figure out a general rule for this, how this happens and how you can predict it. So yeah, let's just start off by going over this basic scenario. So we start on number one here. We'll go around. So one will tag number two. Number three will tag number four. Number five will tag number six. And number seven will tag number one. So now we've gone through the first loop. So the only people that are remaining, right? So three will tag the other remaining person, which is five. And then seven will tag three. So in this scenario, seven is the winner. All right. So this is just one of them. So at first, this will seem kind of random, but we're going to try to figure this out. So we're going to go over a few more scenarios. I'm not going to draw stick figures for all of them. So let's just go around. So if we have one person, obviously that person is the winner, right? If we have two people, two, if we start on one, one would tag two, and then one would be the winner again, right? And if you have three people, so we have it like this, right? One would go on to tag two, and three will go on to tag one. Winner here would be and if we go on to four people here, we go 1, 2, 3, 4. One would go on to tag two, three would go on to tag four, and one would go on to tag three. So one would be the winner again. So can you guys find a rule from this so far? Is there anything we can see in common here? It seems kind of random, right? All right, well, for now, it's going to be like this. So let's go on to test a few more. So let's go and try 5 people. So 1, 2, 3, 4, 5. Keen, you want to go through this scenario?
I haven't really found a way yet.
Oh, no, just go through with it. So like, if we start on number 1 here, how would this go? So if we go through just eliminating people.
So like 1 tags 2.
Yep.
And then 3 probably tags 4.
Mm-hmm.
And then 5 probably tags 1.
Yep.
And then 3 probably tags 5, or 5 tags 3.
3 would go in tag 5. So the winner here would be 3, right? So let's write that down. So this pattern here doesn't really make much sense, right? So let's go and do a few more. We're going to go all the way until 7. So we'll do 6, and then since you already did 7 at the beginning, that's where we're going to end for now. So let's do 7. Oh, to 6. 2, 3, 4, 5, 6. So you have 6 people here. How would this work? Olivia, want to give it a shot or just go through this?
It's okay. I'm just going to watch.
All right. So if we go start on 1, right? 1 would tag 2. This is pretty basic. 3 would go and tag 4. 5 would go and tag 6. And then now we go back to remaining people. 1 would tag 3. 5 would tag 1. So the remainder here, the winning person here is 5. So now we start to see like a sort of pattern, right? If we go starting with 1s, and we go into 3, and we go to 1, and we go to 3, and to 5. And then we already know that 7 has a winner of 7. So what can we sort of tell from this here?
Wait a minute. I'm thinking something. On the lose things, on the place where it shows lose, it's 1, 2, 3, 4, 5, 6, 7.
What do you mean?
Like if you would look at the people. Oh wait, no. The winning thing. Why is it 7 that wins? It's
7
not
that
that
wins?
there's 7 people, so that's 7 definitely wins. Wait, couldn't 2 start and then tag 3?
Well, that's what we're starting to. We're assuming that we always start from number 1. So that's how we're
But
gonna
one
do.
couldn't tag 7. One could tag 7.
Oh no, we're always gonna go counterclock. We're gonna go clockwise.
Oh.
So
Okay.
yeah, so we can keep things consistent. We can find out a general rule for this, right? Oh, someone else entered the waiting room.
Who is it?
Oh, Leo, hello. All right, hello, Leo. So yeah, we're going over the Josephus problem. So yeah, so I'll explain it again real quick.
But why does everybody lose? Because like 1 tags 2, 3 tags 4, and then 5 tags 6.
Well, the point is that we always have one person remaining, right? So for Leo, I'll go over the problem real quick. So I'll go and explain it. So basically, you have a group of people in a circle, right? And then so we'll always start from number 1, and then we'll go counterclockwise. And then so each person will tag the person next to them. So if we start on 1 here, then 1 will go to tag 2. So 2 will be out, 3 will go to tag 4, 4 will be out, 5 will go to tag 6, 6 will be out, and then 7 will go to tag 1, 1 will be out, and then after that we'll continue again. So 3 will tag 5, and then 7 will tag 3. So 7 will be the winner. So that's sort of like what we're doing.
Wait, why does 3 not tag 7? 3, I think 3 is supposed to tag 7, isn't it?
Oh no, if we go clockwise here, then 3 would have to tag 5, right? Because that's the next one that comes up.
Yeah, but I see.
Yeah, 3 would tag 5, and because 7 is here, we go clockwise again, that would tag 3. Okay, so with what we found so far, can you guys sort of come up with a pattern? Can you see any sort of pattern in this with the number of people and the winning number? This list is sort of messy. Here, I'll write it again. So if we have, we'll use n to represent number of people, and then winning number. So what we found is if we have 1 person, the winner will obviously be that person. If we have 2 people, the winner will be number 1. 3 will be 3, 4 will be 1, 5 will be 3, 6 will be 5, 7 will be 7. And then just to save time here, I already did 8. So 8 will be 1. So from this, can we sort of come up with any rule for this? Anyone have a guess? Well, see all the ones where you have 1. So 1 is sort of self-explanatory, right? If there's only 1 person there, he's no one to tag, so he would be the winner. Another person where we have 1, number 1 is the winner, is when we have 2 people, right? Also, when we have 4, so here I'll put a little star next to each one of these. 2, 4. We also have 1 for 8. So can you find a little pattern between this for 2, 4, and 8?
2, 4, and 8. The winning number is always 1.
Yeah, right. So what did 2, 4, and 8 all have in common? Does anyone have a guess for this?
They're all even number.
They're all even.
Yeah, they're all even numbers, but also.
Wait, but why is 6 not even?
No,
6
because
is
they're
also
all
even.
multiples of 2.
Yeah, so David's got the right one, right? So
Wait,
they're
but
all
what
multiples
about
of 2 here.
6? Could we see 6 again? Because 6, I think, should end in 1.
Yeah, no problem. We can go over 6 real quick. What we found is that 6 does not end in 1. So assuming you
Wait,
start
but
from 1.
1 destroys 2,
Mm-hmm.
and then 3 destroys 4, and then 5 destroys 6, and then 1 destroys 3.
And then
And then
5 would go into.
Destroys 1. Oh, that makes sense.
Yeah, so this is kind of interesting, right? We find that not all even numbers do this. So we can check this, right? We can check 10 as well. So let's go ahead and check 10 real quick. We're just gonna try out these patterns that we see. Oh, it's kind of messy here.
1 destroyed 2.
Let's let me move the one over.
Whoa. You're moving the 1.
Okay, yeah, so we'll start from 1 again. So
1
1 would go
destroyed 2. 3 destroyed 4. 5 destroyed 6. 7 destroyed 8. 8 destroyed 9.
oh
I
wait.
mean 9 destroyed 10.
Mm-hmm.
And then 1 destroyed 3. 5 destroyed 7.
Mm-hmm.
9 destroyed 1.
So 1 can't be a winner, right?
Yeah, so then 5 destroys 9.
So our winner here for 10 is actually 5. So that's pretty interesting, right? So from this, we sort of realize that, well, this is kind of cramming it in. We realize that not all even numbers do this, right? So it would most likely, it looks like it's a power of 2. So if the number is a power of 2, it looks like the winner is 1.
Wait, but 10's a power of 2?
A 10's not a power of 2. Yeah, so by power of 2,
I know, like, 2 to the power of 5. Isn't that 10?
oh no, so like 2 to the power of 5. So that really means that we're just multiplying 5 2's.
Oh, okay.
So
I
that's
was
what 2
thinking
to the
of,
5
like,
is. Yeah.
okay, yeah.
So,
Because, like, I'm only good at powers of 10.
oh yeah, power of 10 is this. Okay. So like what we found is they're all powers of 2, right? So from this, what would be the next power of 2? So 2 here is to the power of 1. 4 here is 2 squared. And we have 2 to the third. So what would the next one be? 2 to the fourth, right? After this, we just continue this pattern. We can try this out. Okay, so 2 to the fourth would be 2 times 2 times 2 times 2, right? So that'd be 16. So 16 is a lot. So yeah, we'll try out 16. So I'll just breeze through this really quickly to see if we can find this pattern. Let's not.
Wait, now are we doing 12?
We wouldn't do 12 because 12 is not a power of 2. We will want to continue up in powers of 2 because that's the pattern.
So 14 is a power of 2?
No, 14's not. So the next power of 2 would be 16, right? Because 14 you can't get just by multiplying 2's together.
Oh, I see.
Yeah, so anyways, we're gonna go back to figuring out the rule for 16. Oh, this is kind of cramming it in. I'll move this over just a little bit.
You're just making everything move.
15 and 16, right? So if we start from 1, right? So I'm just gonna go through this.
I think you
quickly.
should move the 1. The 1 looks like 106.
Okay, I'll just put a circle around it. So we start from 1, we go knock out 2, 4, 6, 8, 10, 12, 14, and 16, right?
And then we
So-
knock out 5, 7, 5, 9, 13.
Okay, so what did you guys all realize here? So what do we all knock out? We knocked out all the even numbers, right? We got 2, 4, 6, 8, 10, 12, 14, and 16.
I can see that.
Yeah, so this always happens. So now after the first one, right, we've gone through here, we're back to 1. So 1 will knock out 5, 5 will get 7, 9 will get 11, 13 will get 15. And then we're back to 1. So 1 will knock out 5, 9 will knock out 13, and then now we're only left with 1 and 9, and then so 1 will take out 9. So we find that 1 is the winner again. So does this seem like a rule that we can sort of define now?
But I think we should try one more number.
We'll try one more number?
Yeah,
that's gonna be 32, so that's like a lot.
Oh yeah, 32, I get it. How about you just write 1 and 2 and then duplicate that over and over until you have 32?
What do you mean, like just 1 and 2's only?
No, you can just write every number, but then like just gonna take a long time.
Yeah, well,
But I think we could trust it.
yeah, it's gonna take a long time, but I've already done 32. So like when I was like preparing for this, so we also know that 32 is one. So now we know we've proven, or we haven't proven, we found something, right? That if it's a power of 2, the winner will always be 1. So can you figure out a reason for this?
So
Yeah, go ahead.
never mind. Never mind.
I
Okay.
think I got
I was
it.
just talking about something else.
Yeah, so what do you want to talk about? Okay, never mind. Oh wait, do you have something to say?
No.
Okay, Kimi, do you have an idea? How this would
Yeah,
work?
like I think something about this, like when you knock out things, it causes like a chain reaction. And then like to keep one on the board, they have to knock out stuff that does not affect one. So that like if we say 7 knocks out 9, 8 knocks out 9, like if 9 knocks out 1, then that's gonna be bad. So we have to have like 8 knocks out 9, and then 9 can't knock out 1, so 1 can continue knocking out.
Sort of. So let's go back and just do easy one first. So we'll just do 8. Let's try to figure out what happens, right? So on the first one, we knock out all the even numbers, right?
Mhm.
So 2, 4, 6, 8 is gone. And then we're back to 1 after the first rotation, right? We're back to number 1 where we started. And then I'll go again. 1 will knock out 3, 5 will knock out 7. And then now we're just back to 1. So 1 will have the chance to knock it out. So if we have an even number, it seems like after every single rotation, we'll end up back with 1, right?
Wait a minute, but 8 did not get 5.
What do you mean?
Is the number 8 a power of 2?
Yeah, 8 is power of 2. 8 is 2 to the third, right? So 2 to the third is equal to 2 times 2 times 2.
Yeah, but I don't think we wrote it on the board. I think the board says 2 was like 5. 8 was like 5. Oh, yeah.
8's here, yeah.
I was thinking about 6.
But going back to this, so we found that if we have an even number, or if you have a power of 2 here, we'll always end up back at 1, right? So is this true for the other ones? If we go to 4,
I think.
if we start with 1 here, we'll go knock out 2, 3 will knock out 4. We're back with 1, and then 1 can knock out 3. So that seems to be the reason why if we have a power of 2, we'll always be, the winner will always be 1.
What about 64?
A 64, yeah, that would also be the case, but if we have some extra time, I guess we could test that at the end if you want to. But for now, we're gonna skip over that because that would take a long time.
64 and then 128. Will that work? I'm not sure if 128 is a power of 2.
Yeah, 128 is power of 2. 64 times 2 is 128, right? And we know that 64 is power of 2.
And then 256.
Yeah.
Is 256 a power? Because that's. Yep. Oh, yeah, that's odd numbers aren't supposed to be a power.
All right, so now we've already figured out why the power of 2's work, right? So can you figure out the reason why we have 3 here? We have 3, and now you have this, and this, and this. So we have these weird numbers that pop out, right? So they seem to be, it goes 1, 1, 3, and it goes back to 1, and now it starts climbing in 2s, right? You also see that.
Like it first climbs out, it goes like from the number it climbs 0, and it climbs 2, and then goes back 0, goes back 2, and then adds 2, and then adds 2, and then adds 2, and then minus is 6 for some reason, and then plus is 4.
Mm-hmm.
It's just so random.
Yeah, it's sort of random now, but if we extend this a little bit more,
wait a minute. Oh,
you can sort of find it, right? So we notice that at every single power of 2, it'll reset, right? It goes to climb up, and then once you get 8, it resets. Or not exactly, but it sort of goes back down. So let's try to figure out a pattern for why these. So let's go back to 3, and let me find a clean board. So let's go back to 3 and figure out how that's different. So if we have 1, 2, and 3 people, right? So we start on 1, 1 will go to knockout 2, and then 3 will go to knockout 1. So we end up with 3. If we go up
But
to
what if we go backwards? Then 2 would be the winner.
yeah, we can also do this. This all applies the same way backwards. We're just doing everything clockwise so we can keep it consistent here.
What? It's you get the same answer when it's backwards?
Well, not the same answer, but you can figure out the similar pattern.
Wait,
It
but
would be the same numbers.
does the power of 2 do the same thing?
If we go backwards, yeah, but it'll be it will be a different number, I think. Or
Oh.
no, I don't think it will if we go backwards. Anyways, but getting back on track, so we've already figured out for 3, so let's go to 5. 5 also ends on 3, right? So we already have this.
5 does not make sense. 5 always crashes the game because like it's you can divide it by 10. You can divide it by 2 eventually.
So 5 also ends up with 3, right? So if we start back here, we'll find out that 1 takes out 2, 3 takes out 4, 5 takes out 1. We'll go back to 3, and 3 would take out 5, making 3 the winner.
3 would take out 4 again.
Yeah, so you guys see like a sort of pattern to this? Anyone?
No.
All right, so we can't figure out a pattern logically. We can try to figure this out mathematically, right? So we have a baseline of the numbers of powers of 2. So how can you write 3? We can write 3 as 2 to the 1 plus 1, right? That equals 3. And we can also write, let's say something else. Let's go to 7, right? 7 could be written as what? 2 squared plus 3, right?
Yeah.
So you could write these as powers of 2. So what that does for us.
Couldn't you do 2, 3? Oh yeah, 2, 3 minus 2. 2 to the power of 3 and a minus 2. Wouldn't that work?
2 to the 3 minus 2 would be 2 to the 3 minus 1, right? 2 to the 3 would be 8.
Oh yeah, yeah.
Yeah, but going back, we can rewrite 7 as 2 squared plus 3. Yeah, Olivia said in chat, 2 with the power of 2 equals 4 plus 3 equals 7. So yeah, you're right. So if we draw this out.
6, 7. 1 knocks out 2, 3 knocks out 4, 5 knocks out 6.
Oh yeah,
Wait a minute.
also, this is not related to the math, but the Zoom is gonna like close itself in a minute because I do not have the membership thing. So if you guys ever just get kicked out of the Zoom meeting, just rejoin back to the same link. It'll be the same one because I don't have the paid Zoom account for this one.
Oh, we have like 30 minutes.
Okay, yeah. Anyways, so back to this, right? If we have, what can we do with this? We have the 2 squared, so we'll figure out that first we'll do the first round pretty normally, right? After the first one, I'll get to. Actually, the Zoom is ending in less than a minute, so yeah, I'll make a. You guys can all leave, and then we'll join back in, so this meeting doesn't like end it.
Should we leave and then join back in?
Yeah, so just